So last weekend, I went down to the basement of my house to put some stuff or get some stuff, and then I realized I have some water on the floor. It was already 2-3 centimeters. And I found out I had a clogged drain pipe, and so the water came back and filled the floor. So fortunately, that was just the pipe for the dish machine or dishwasher, and not of the toilet. And also it was on the wall, so I could easily fix that. It was not nice, but was doable. But now the question is, why is that somehow related to Docker? The thing is, after that, so I realized I just want to use my dishwasher. I normally don't care about all the pipes, and I expect that it just works, and normally it just does it. And the same goes also for application developers. So if I want to deploy my application with Docker, ideally, it just works when I deploy it to production. I don't want to care about the things below my Docker container, because it should just work. And orchestration tools claim to solve these problems, and there are quite a lot of tools. And in this talk, I want to talk about Amazon ECS, the EC2 container services. The documentation says it's a managed container service that starts to schedule containers based on resource needs, isolation policies, and availability requirements. Sounds quite good. We'll see if that really is that easy. So about me, my name is Philipp. I work at Scout24 as lead platform engineer now. I've worked before at AutoScout. Now the job here at Scout is to build tools and services for our application teams, for AutoScout and also for Immobilien Scout. I think these companies are known in Germany, right? Okay. And so our goal is to fill the gap between the stuff that AWS delivers or has already, the managed services, and on the other side, stuff that is needed by our teams. So we don't want to abstract the cloud and AWS. AWS is still our platform, but we, as platform engineering team, we want just to see what are the pains of our teams and how can we solve that. And we try that with the approach where we will build products that then can be used by the teams. They are not forced to use it, but we want to convince them by the easiness of use and also, I think that's the main reason. I'm also Docker captain, and who of you knows the Docker captains program? It's always almost none. Okay, Docker captains program is similar to the Microsoft MVP program, or I think Java Champions, but smaller. There are around 70, 80 Docker captains worldwide. And I think we go now through some slides where I show how can an ECS cluster and also ECS services, how can we deploy them, what tools does AWS provide, and then also see later some advanced topics and maybe also some pitfalls, what can happen and what we learned also from production. One thing, maybe I explain how we use ECS is, as I already explained, we have the setup with the platform engineering teams and the application teams. And our goal is to provide a managed ECS cluster for our teams, so that the teams just can take care about their containers and how they deploy the containers to our cluster. So they are not responsible for the cluster anymore. It's like a managed service from AWS, but just from our team. And they have to take care about their application and their running container. Who of you worked with ECS already, or had a look on ECS? Okay. An ECS cluster is basically a set of container instances, and container instances are EC2 machines with special requirements. There's also an optimized AMI provided by AWS that should be used. You don't have to, but it's better. And the ECS agent that runs on each of these container instances. It's also a Docker container that runs. And the good part here is that the whole cluster management is done or is handled by AWS. We don't have to take care or set up any key value store to store this information. And we also don't have these different kind of nodes like manager and workers. They are just the same container as instances. There is no differences, and they communicate through an API. So the ECS agent communicates with the backend at AWS, and starts then the containers. This can then be wrapped in an autoscaling group. And then is the question, how can we create such a cluster? We have 4 different possibilities from AWS. The first one is the AWS console, which is the web UI. So you can click through the UI, you can get a nice assistant, fill out some parameters, what name, what instance types, and so on. And then it creates the cluster for you in the background, and a couple of minutes later you have the cluster. It's easy to start, but it's not. You cannot automate that because you just have to click around on the website. So the next thing is the AWS CLI. There's a command line tools. And it's a little bit harder to get started with, and because you have to create a lot of resources so resources means in AWS, resources, for example, an autoscaling group, a launch configuration, load balancer, that are resources, and you have to create them to set up such an ECS cluster, and you have to set it up in the right order. There are sometimes some dependencies, and when you want to run if you want to make some updates, you have to make your scripts aware that these resources can already exist, and then you have to check them, maybe update them, or if they don't exist, you have to create them. So such a script can get very complicated and very long, and that's also not what you want normally. And therefore, the ECS CLI is also available, which abstracts all these complexity, and you can create a cluster with one command. That has also some downsides, of course. It's not that flexible. You have only a few parameters, the most important ones, and that's it, and you have to live with that. So it's quite a good solution if you want to create a cluster to start a POC or for development purposes, or if you want to try out something. One command, the cluster gets up, and you can play with it. But it's not something that you want to have in production. For production, I love CloudFormation. CloudFormation is a service from AWS where you can define in a configuration file like YAML or YAML or JSON syntax what kind of services you want to have. So you define the desired state of these resources. You send that file to the CloudFormation service, and then CloudFormation takes care about creating all these resources. It takes also care if these to update these resources and takes also care about the dependencies in between. So it's very easy, and also a change is very easy. You just change your configuration file, send it to CloudFormation. CloudFormation does all the stuff what needs to be done. Maybe it creates or replace some resources. I think it's good to have a look. This is a small example. I think, I hope you can read that a little bit. I think there are 3 parts in it. There are parameters where you can parameterize the whole template. For example, you can define instance types as a parameter, and then you can run this template several times, and you define a cluster with the M4 instances and another one with T2 instances and so on. Then you have a block for all the resources, and in the end some outputs, because CloudFormation generates all these resources, or it generates a name for all these resources. You don't have to specify a name. You get a generated name, and this can also then be returned and then used maybe for further stacks. For example, what we then also can see is the cluster name of the ECS cluster. When CloudFormation creates the ECS cluster, this name gets generated, and you can return that, and then use this name for your services, because you have to tell on which cluster the services has to be deployed. So that was the part of the cluster. Now we want to deploy an application. So we have an image. We can use any registry that we want to. AWS also provides a registry, the ECR, the Elastic Container Registry. The advantage here is that it fits very well with IAM. IAM is the identity and access management on the AWS, and here you can define roles and allow each role to access specific resources or deny that access, dependent on your needs. So, for example, you can say, okay, my application gets access to a DynamoDB. And this role, in that example with the registry, you can say, okay, this cluster is allowed to pull the images, but it's not allowed to push images to the registry. It's only allowed for my CI pipeline to push these images. Or also very specific images, so for each repository, you can define who is allowed to pull or to push. So that's a big difference between some other registries. So if we would then want to deploy our services, we have to describe that. One part is the container itself. We have to define the image, the port mappings, some network options, and here we can also define the Docker options. So unfortunately, not all the Docker options that you know from Docker 1 are supported, but the most important one. There are already some discussions on GitHub to support more of these parameters. This is then wrapped inside the task, the task definition that can already be used to start a container on an ECS cluster. And that means it just runs or starts one instance, and this instance runs as long as the process inside your Docker container is running. Here we have then the possibility also to define a task role. So again, we can set up a role on IAM and define the rights and the permissions for our container. And with the example with the DynamoDB, also we can say, okay, this container is allowed to access that DynamoDB. They belong together, and no other service then is allowed to access this DynamoDB. And also the task placement constraints can be defined here. That is a new option then also on AWS, where you can say like with the Docker Swarm mode or so, you can define some constraints where your container is allowed to run. For example, if you have different types of machines in your cluster, maybe with some GPU units attached to it or so, then you can define that it needs special requirements on your hardware, for example. And then when you have an application like for example, a web application, it's quite useful to wrap that further into a service definition. And here we get then all the benefits that ECS takes care about my container. So we can define here the number of instances that I want to run, and ECS then takes care that these instances or this task then are spread across the whole cluster, that I have always the same numbers of instances running and so on. And also what happens when I deploy a new version. So you can define in the deployment configuration, for example, that I want to have at least 100% running instances at minimum, and the maximum is, for example, 200%. So then he creates the same number of instances in parallel of the new version, and then when this has been started and successfully registered the load balancer, it drops the old version or the old containers. But you can also specify another numbers, for example, 50% as minimum. So he stops some containers, adds some new containers for the new version, and then drops the others. But then you have, in that deployment phase, you have then not the 100% of running containers for a small amount of time, but maybe less. But if that is not a problem for you, you can do that as well. And also autoscaling can be configured here for the service. So we see that later than in detail. Based on some metrics, you can say, okay, please scale out or please scale in. So how can I then deploy my ECS service? Again, we have the same options. We can do that in the console, again, with some nice UI to click through. We have the CLI, which is not that complicated because we have just to register the task definition and start the service. It's 2 or 3 commands that you have to do. Nice thing on the ECS CLI here is that it supports the Docker Compose file. So if you have a Docker Compose file already, you can use that as source, and based on that Compose file information, it generates then the task definition and which is the task definition in your cluster and starts the service. That's why I wrote for infrastructure as code as partially. And also with CloudFormation, you can define in parallel or in addition, you can define also the task and the service as we can see here. That's so like a whole example of an ECS service, what you have to write down. The only reference that you need as a parameter is the cluster name, where it should be deployed. And then you send that to CloudFormation, and CloudFormation does everything. And later, a couple of minutes later, or seconds even, then the service is deployed and started on your ECS cluster. I think nice is also if you define also the version number. Daniel showed that already. Don't use latest. That you can also have it as a parameter. Put in your build number, for example, and attach that to the image name, and then you be sure that you have always a very specific version running of your container. Okay. Most of the services needs to be accessed from the outside. The best way to do that is with the load balancer. And here AWS provides us two different load balancers, the classic load balancer, or the ELB. It's a layer 4 load balancer, and it has static port mapping that we see then on the next slide, or next slides, why this is not the best solution for containers and the ECS cluster. And therefore, also a newer version or a new load balancer has been published by AWS, the application load balancer, which is a layer 7 load balancer. So it works only with HTTP. And has some other nice features. So it provides, or it gives you also the possibility to define some rules how the traffic should be routed. So you need only one load balancer for a couple of services, and then you can do an host-based routing or path-based routing to your ECS services. How does it look like, the ALB? So we have the load balancer has listeners. So I define on which port he should listen, and at least you have to set up one rule, a default rule where the traffic should be routed, and you have a target group that has to be defined, and then all the traffic is routed to the targets in that target group. In case of ECS, the target group is an ECS service, and the targets are the containers or the tasks that are running. The good thing is we don't have to take care about that. We just have to tell the ECS service the name, to give the target group, and that's it. All the containers that that are started by ECS are then automatically added to the load balancer. And once the health check is green, then also the traffic comes into these to these containers. And you have also a specific or a custom health check. So for each target group, you can define also the health check, what your application or where your application is listening to. What I said is that the classic load balancer, the ELB, has the problem of static port mapping. On the ELB, you can define only one port where the traffic should be routed. And when you do that, for example, here with port 80, it goes to the container instance on port 80, and then it gets forwarded to your container, maybe also on port 80 or some other port. But the host port is then blocked. You cannot start a second instance of your container on the same host. So if you want to scale your containers, you have also to scale the whole cluster, which does not make sense. And you can also not set up any other application which needs the same host port, because then it has to run on a different machine as well. And so the ALB provides a dynamic port mapping. So you define the no host port, or define 0 in your task definition. And then the ECS service and the load balancer look on which host is the task started, which ports are free, and then they pick randomly a port, and then the service or the task is then registered at the load balancer with that specific port. And that gives us the possibility that we can run as many instances as we want on the same machine. Everyone gets a different port. But we don't have to scale our cluster for that. Yeah? Ooh, yeah.
This is level 1. What is the ALB doing when this container instance should talk to one other container, but it's also scaled?
And what I would do is, I think if I get the question right, is how can containers talk to each other, right?
Yeah, when I have one type of container, container A, and I have many instances of them.
Yeah.
And the load
What you would define is just the host name of the load balancer, or if for example, the host name or the path. But in that case, I think the host name would be better option. And then you tell your service A, the service B is reachable with that host name, and then it goes to the ALB, and then it's routed to another target group, and then to the other service, and then you get any random instance of that service.
And this is done by the same ALB, yeah?
Yeah.
I don't have a second ALB on the next level.
You don't need another one. You can set up to, I think, 75 is the current limit of these target group, for these rules. And in each rule, you can define the host header that it should look for, and then just need one load balancer, and it can run up to 75. And I think it's not a hard limit, but a soft limit. So maybe even more. Okay, now we have set up our cluster. We can also divide that in two different stacks. So one is the cluster, and we can also shift that responsibility to different teams, like we do that now. So the one team is responsible for the ECS cluster, and the other team is responsible for the ECS service. And at some point, maybe the ECS service becomes successful. It gets a lot of traffic, and we have to scale. Let's see what is needed to handle all that traffic. For example, we start with one task in one container instance, and we get some traffic, and it scales up the task. So we have now 3 tasks running, and we have to scale more. So we need an additional one. So we have 2 possibilities then. We can scale then the cluster and add a new instance before, or we can wait until we really need we really have to scale the cluster because another task is already pending, and then start the second container instance. And once we have that, it gets scheduled, and then maybe it gets later, at night, the traffic goes down, it scales also down, then also the cluster sees, I can also scale down. It stops one of the container instances, then the ECS scheduler sees, I had 3 instances running, and currently there are only 2, I have to start another one to fulfill my requirements. And the third task is then started again. So how does it work? So we have 2 different kinds of scaling. One, and I think that's the easier part, is the scaling of the service. We get already 2 metrics out of the box from AWS, which is the CPU utilization and the memory utilization. And based on these metrics, I can set up some alarms. And when this alarm is triggered, I can trigger an scale event, and then it scales out or it scales in. This works quite well for the services, but it gets a little bit more complicated for the cluster. For the cluster, I get 2 additional metrics out of the box. One is it's the reservation for the memory and the reservation for the CPU. So when the ECS scheduler looks at the task definition, it looks how many CPU shares you want to have, and also how much memory you need, and this is then your reserved capacity. And based on this information, it knows, this host can handle another task, or it can scale, or can place another one here, or not. It does not look at the real utilization. So maybe all these services don't need any CPU, or don't need all the memory that they required. But for ECS, that host is already filled and it cannot place another container in it. So what we then came up is that we said, okay, we have to find out when do we have to scale out, or when can we also scale in our cluster. And what we said is, okay, we need to know the maximum size of our containers that we want to run. So we have to define that. And once we know that, and we also know the capacity of the host machines, then we can calculate the threshold when we should scale out. And we can do that for the CPU, and we can do that also for the memory. And yeah, we thought it's quite easy and no problem. And it works also very well if you want to scale out. The problem starts when you want to scale in, because then you have two metrics, and you have to decide, or both maybe say, for example, the CPU says, okay, I have a lot of free reservation, I can scale in, but the memory want to scale out because it runs out of reservation. And then you have a cluster that scales all the time, and you cannot schedule your task. You get in trouble then. Then that's what we said, okay, this is not the best solution. We have to then make the better. We basically need only one metric that says, do we have to scale out or do we have to scale in? And what we do now is we calculate how many of these of our maximum containers can be scheduled, or how much free capacity do we have. And we do that for each host every minute. And this number is then stored as a CloudWatch matrix. And once it gets, when it gets below a specific threshold, for example, 1, if you cannot place any further container, then we say, okay, this is now we have to scale out. And the same applies then if we want to scale in. You also say, okay, if we have free capacity for at least, for example, 3 containers of our maximum containers, then we have enough capacity and we can then also scale in the cluster again. And that works then very well. It's just a small lambda which writes the numbers, and then everything else then works out of the box with the normal AWS tools. And this works also very good in combination with the bin packing strategy. So you can define for the services the placement strategy, and you can say, okay, please use bin pack, and maybe also spread that across the availability zones on AWS. And then the ECS schedule tries to fill in one node as much as possible, and then starts with the second node. And if you use that in combination, you have almost no overhead of free resources on your cluster. I wrote that a little bit in more detail on my blog. The other thing is that you have to deal with is the node draining. Node draining is needed if you want to replace the host because you want to install or get a new machine with the newest updates, for example. And then the ECS knows about node draining, and you can tell, okay, please drain that node. But the problem is that that the autoscaling group below does not know about that. So the autoscaling group in AWS knows only about the EC2 machines and is not aware what is running on top of that. If that's your application or if that's an ECS cluster, it doesn't care. And you have to do that part by yourself. So the solution, it's also based on an AWS blog post, is that you, whenever the EC2 instance gets terminated, you can it triggers an event, and you can subscribe to that. It's called lifecycle hook. Start a lambda, tell the ECS, okay, please drain that node. You wait until all the tasks are placed on other nodes. And then you say, okay, please, autoscaling group, you can continue with the termination, and it release that lifecycle hook, and the autoscaling group then continues and terminates that instance. It's not a big deal, but unfortunately, you have to do that by yourself. So it's not built in, or not. I hope that they do that at some point. Yeah.
When you say subscribe, then you mean that there is some event and lambda is triggered, or do you have like do polling?
You get an event. It's sent to an SNS queue, and at the end of the SNS queue is the lambda. Yeah, and it's always when the status of an EC2 machine change. For example, from running in terminating or terminating, you can do your own stuff, and then either with a timeout, or you can say, okay, please continue, and then it's terminating, really terminating, and then it's at some point it's terminated. Yeah, I think some best practices if you run such a setup is please provide an update policy in your autoscaling group. Often you don't see that in the templates, but it's quite important that it waits for the resource signals. So normally the autoscaling group works quite well with the load balancer setup, and if you run your application on an EC2 machine and it gets registered on the load balancer, everything is fine because the autoscaling group waits until the load balancer says, okay, this machine is running, and then it continues. But if you don't have that set up, then the autoscaling group just continues by itself. And if anything goes wrong in your setup and the ECS cluster comes not up on that machine, for example, Docker is not running or the ECS agent has not been started, then you replace your whole cluster or all the instances of your cluster in a couple of minutes with non-working machines, and then your cluster is gone. So you have to weigh that, and then also the second trick, ensure that the Docker and also the ECS agent is running. So part of the init script of that machine is what I do is an health check to see if Docker PS also returns the containers that have to be started. And once that is successful, then I can also send the resource signal back, a success signal back, and then the autoscaling group can continue. And I'm not sure if you have worked with that setup. So CFN init is an additional script in CloudFormation that is called in the user data. So the user data is the place where you can add some custom scripts. And the CFN init is some helper tool where we can also define what should be done. For example, which file should be created, which service should be started, and so on. You define that in a declarative way. You don't have to script that. And if you do that in that way, the user data stays always the same, and that's a problem, because if the user data does not change, the autoscaling group will not don't see any changes and says, okay, I don't have to replace the running EC2 machines. So we have to force the autoscaling group to replace these machines. And one trick is to just put the build number in that script in your CloudFormation, and then the user data gets changed every time you have a new build, and then it triggers automatically that all the machines should be replaced. Yeah, volumes is something that is not supported or built in, but often or sometimes used. For example, if you have a Jenkins setup or Elasticsearch or such applications where you have to store some data. AWS provides here two different options. You have on the one side you have the Elastic Block Storage, the EBS, which is quite fast volumes, dependent on what you define and also what you pay. The problem is that it's limited to one availability zone. It cannot be moved to another one. There's also no automatic scaling of this volume, so you define the size. You can now also change that, but it's not expanding automatically. So if you want to use these things, then yeah, you need some additional tooling like Flocker range or so that these volumes get automatically mounted to that host where your Docker container then is running. The other option is the Elastic File System. This is then shared across all the availability zones. It scales automatically, and you pay only what you actually need. So the more data, the more expensive, of course, but you don't have to care about anything else. The only problem is have a look on the performance. So the throughput is then also related to the volume size. So the bigger the size or the more volume you have, the more throughput you get. But yeah, you can check that in the documentation and see if that fulfills your requirements. I think important part then also of containers is security. And I already explained about IAM, the Identity and Access Management. And there are 4 different roles that you have to set up. That are just the default names. Yeah, you can see that. And you need that on different levels. The first 3 are are always the same. Basically, if you set up such a cluster, you have the autoscaling group or the autoscaling role, where you allow the autoscaling group that it can do that as read the matrix and then do the autoscaling. The container instance role is then for the EC2 machine. So you allow the machines to pull that images from your registry, and also to register or deregister that container instances on the ECS cluster. The service role then, you have to give that service role then the permission to register or deregister all the tasks that has been started on the load balancer. And the more important one for you then is when you define an ECS service is a task role, because here you define then what your service is actually needing. And I think a good overview is, I think you can see that im.cloudonout.io, a good page from 2 brothers, I think also here they are from Stuttgart or so, which provides a good overview of all the EAM permissions that you have in one place, because on the AWS page it's spread for each service, and here it's in one place. How does it work with the task role? So normally, if you have an EC2 machine, you get automatically a metadata service attached. It's accessible on a specific IP address, and the AWS SDKs automatically check that one and get the credentials, and then access with that temporary credentials, access then the other AWS services, for example, DynamoDB. But for containers, it's get a little bit more complicated. So whenever the ECS agent starts another task, it gets an UUID as an environment variable automatically, and then the AWS SDK checks if that environment variable exists, and if yes, then it asks another IP address for the credentials. It does not ask the metadata service anymore, but this IP address. And there is an change in the IP tables, so that this call then gets routed to the ECS agent on that local machine. And the ECS agent knows, okay, with that UUID, I have that role registered, and then it asks the metadata service, okay, please give me the credentials, and then returns it then back to the task. If you provide your own AMI, you have to do that IP table changes by yourself. With the ECS optimized AMI, get it out of the box. But the problem here is that this still works. So inside your container, you can still ask the metadata service, and then you get the credentials of your host, which is, let's go back, where we have here ECS container instance role. And yeah, when we realized that, we identified that by accident, of course. We talked to the AWS guys, and then they updated also the documentation with some warning. And what they said, okay, the thing is, what you can do is change your IP tables. Don't allow the containers to talk to the metadata service anymore, which can be also a disadvantage, because sometimes it asks the metadata service also for the current region or some other information that can happen inside your application. But then this is also not possible anymore. And also, the second advice was give the instance role only the needed or the credentials or the permission that it really needs. But still, this is already the minimum permissions that you have to define, so you can deregister that container instance on the cluster. So I think it's very, very important to set up the IP tables rule here, that it cannot access that metadata service. Another setup that we have is, and the problem is if you work cross-account. So if you have multiple accounts, and in our case, we have the cluster running in one account, which is where we are responsible, and each team has its own account where they run all the other services, databases, and whatever. And therefore, they have also to provide the role, the ERM role, that for their task. And one problem is that it cannot, AWS or the ECS service cannot assume that role from another account. Some services can do that, but the ECS service cannot do that. So what we did, we added another, we added that cross-account proxy in that flow. So when we start the container, the only thing that it gets on permission is to assume role. And then when the credentials are requested, in the cross-account proxy, we look up the role that has to be defined by the team. Then we assume that role, get that credentials, and return that credentials back to the container. And then, yeah, everything works like before. So that is only so this hack then, or it's not a hack, but but this is then needed if you want to work cross-account. Yeah, I think where I like ECS very much is that it's a very stable environment. So the underlying infrastructure with EC2, the old scaling group or so, these are already some tools and services that have some years, or they work already for some years. They also catched up now with all the important features like the task placement engine that some other orchestration tools have already. And it works quite nicely in combination with the other AWS services like CloudFormation, or also with ERM, which is very important for us. We missed already something that we did not talk about, or where there was no time, is topics like networking, logging, monitoring also. I think that would be another talk. Quite interesting is also the parameter store. It's like a vault or so where you can have some secrets and then access that from your containers, so you don't have to provide that as environment variables also, which is quite good. There's some things that I wanted to have. Some Docker features, or not all the current Docker features are supported. For example, the health check is not used. Of course, it doesn't matter if you have that inside your Docker file, but it would be nice if the health check would be used as also for the load balancer automatically. Then you don't have to define anything else. Also, security groups are missing for the containers, and also with the volumes, you have to use some third-party tools where I wish that also AWS, where they provide already the volumes with EBS and EFS, that they can also provide the tooling around that. I don't have to take care about that anymore. Okay, that's it. I think one thing, if you want to join the DockerCon in Copenhagen, it's in October. With that code, you can save 10%. And maybe we see us in Copenhagen. Thank you. Yeah?
I missed one thing that you said before. You said that you use a third-party tool to mount volumes on ECS.
Yeah.
What is the name of this tool? I missed it.
There are some tools, Ranger, Convoy, and we can check that afterwards.
Okay, perfect. And another question is, why didn't you go directly with a solution like Elastic Beanstalk, for example? When you just tell, like, this is my code, this is the container, just deploy it, and it will take care of it.
That's a good question. We did not look so much at Beanstalk because it gave you, at that point when we had a look at Beanstalk, it did not have all the possibility that I think it has now. But it's still limited in the things that you can do. So here you can fulfill so you can customize all the other requirements and also do more stuff with the Beanstalk. It's kind of limited. You can only do what AWS offers within that scope. Yes?
I have a really big backend architecture that is deployed, that has to be deployed over all the world. Yeah? I know that they have a data center in Frankfurt,
Yeah.
maybe one in USA or something like this. When I'm creating my backend here and the infrastructure, should I? There is a possibility to synchronize it, or does AWS this for me, or should I really start from the beginning?
Okay, the setup on AWS is that you have different different regions. One is, for example, Frankfurt, in Ireland, I think London now. I think there are in around 20 regions around the world. And they work independently from each other. And in each region, you have availability zones. And you can, that right that you get from AWS is optimize for an availability zone outage, that you can handle that. So you use all the availability zones that the region provides you. And then you're quite safe. Also a complete outage of an availability zone is not that likely, and even if that happens, they are on the same location, but they are separate. And if you do the normal setup, we will see also in the templates that you have normally in setup where you distribute the application across two or at least two or often three availability zones, and then you have already a good setup. If you want to make your service globally available and also I think with a short latency to your customers in that country, I think that's another challenge. As you can do that, and but it gets a little bit more complex, I think, than we have to talk in detail.
Yeah.
Okay, another question? Okay, in the application load balancer, the target group is the same, or that's what you register within an ECS service. You tell I can show you an example. That's what you tell the ECS service, and then the target in that target group are the tasks that has been started by the ECS service. So you just have to make the link between your ECS service and that target group. So it's just a name. You just say, okay, that target group. Let's see. Okay, I think it's here. Everyone else can also go for a beer if you want. So what you define here, we do it here. So you create that target group because that the target group needs to exist as for your rule that you have to define. So the rule says, okay, every traffic with that host header goes to that target group, and that's it. It's just a placeholder, that target group that you have to define. And then you tell the ECS service, please register all the tasks automatically as part of that target group. You just reference that target group inside your ECS service, and everything then works out of the box. Because you can, of course, create that targets manually as well if you want, or if you have different setup. You don't have to use the application load balancer only for ECS. You can do that for any other application as well. And then you can do that also manually. But the thing is that the ECS service takes care about that and registers and deregisters them automatically for you.
And how is the relationship between your ECS service and your container instance then?
The relationship between the ECS service and the the service knows how many instances should run. It knows also how many are really running, and if needed, it starts a new instance based on then some rules. So you have the task placement constraints or the strategy where you can say, okay, this should be run on that host or so. So there are some rules, and it checks which host has also the free capacity where you can start that container instance. And once that is done, it's started on that host, and yeah, that's it.
And can you clarify me also the lambda? Because at a certain moment in time you brought in a lambda in order to phase out the service. So are you doing edge computing there, or?
I think you mean for the scaling, right? Or for node training? That's a problem because of the disconnection between the autoscaling group and the EC2 instances and the ECS service itself, or the ECS itself. So you can tell in the ECS, okay, please drain or set the status on draining for that container instance, and then it stops all these running tasks and tries to place them on another machine. And also new tasks are not placed on that machine anymore. But you have to set that manually. And what that Lambda is doing is it makes the connection between the application lifecycle, the lifecycle of the autoscaling group. So whenever the autoscaling group, or whatever reason, terminates your instance, this hook gets triggered. You get an event. Lambda gets started, and then the Lambda sets the same node that gets terminated. It sets also an ECS, the status to draining. It waits until all the tasks are gone on the machine, so you have a 0 task running, and then it says, please continue the life cycle, and then the autoscaling group is allowed to terminate that instance. So it just interrupts that process, tells the ECS cluster, okay, please move all the tasks to other machines, to other nodes, and then continue with that terminating. Okay, I think we are not Dominic. Can you maybe please come over and we can talk here? That easier? Okay, then thank you.